Hello, welcome to My Easy Statistics. In this video, we will be discussing about multi-group analysis in Amos. In the earlier videos, we have discussed about drawing Amos graphics and doing regression equation, conventional regression equation, model identification we have discussed, and even we have discussed about model fit. Now we are going to discuss in this session about multi-group analysis. For conducting this multi-group analysis, I am taking an example, a very simple example to understand how multi-group will be done in SPSS Amos. I have in my example 5 variables: age, annual income, education, job experience, and gender. I want to see what is the impact of education and job experience on annual income. In the first stage, what we do is we'll draw a simple model to see the impact of education on job experience. After that, we will be dividing the gender into two groups, males and females, and we will discuss how to do this multi-group analysis in Amos. And in the third stage, we will discuss how to check the significance difference between the groups. So this is a process which we are going to start. Initially, we'll start with a simple model. In the second phase, what we do is we'll divide the total respondents into two groups, that is males and female group. And in the third stage, let us see what is the significance difference, how to test the significance difference between these two groups. Right. Taking this example, I am performing Amos. So I go for Amos graphics. Okay, this is the work area which we are going to have. I want to draw 3 variables, that is impact of education and job experience and on annual income. So these 3 variables are observed variables called as measured variables, or items it is also called as. So let me draw these 3 observed variables. Observed variables are shown with a rectangle or square. Okay, now let me connect this with the impact with an arrow. Okay, now this variable where arrows are pointing is called dependent variable, and the variables which are side table tail side is called independent variables. This is called endogenous variable. Dependent variables are called as endogenous variables, and independent variables are called as exogenous variables. Let me link the file. For doing this, select data file, file name, in this have multi-group analysis is a file name. Okay, so total 500 respondents are there total. I'm saying okay. Let me assign the variables. I'm clicking this button. Okay, now I'm going to add annual income, education, job experience. Done. Now this annual income is called endogenous variable or indicator variable. This is called indicator. Why? Because the arrow is pointing. So indicator variables require error variable to be assigned. Now this error variable is called as unique variable also. Now let me name this automatically by simply saying name unobserved variable. Yes, I got it. Now I want to do analysis properties. in estimation we are using for doing this Amos maximum likelihood method. We have still 4 more methods, but we are using maximum likelihood method in this case. I want to calculate mean and intercept, and in the output what we want to see, I want to calculate standardized estimations, square multiple correlation. Okay, in my earlier videos I explained what is square multiple correlation. You can check those videos for information. Okay, let me go for now calculate estimate. The system is giving warning to keep correlation between education and job experience. I'm not considering it as of now. I want to save the file. I want to save as example, and whenever I save an Amos file, the extension will be .amw. Done. Now once the model is identified, then only we will get the output path diagram activated. If the model is unidentified, we don't get this. In my earlier videos I have discussed how to check this identification problem. The model should be always identified. It may be just identified, but it should be always over identified but never unidentified. Okay, let me see the path now. When I select this, I got the variables. This is the values I got. Now the values what I got is called unstandardized estimations. I can go for standardized estimations, right? This is standardized estimations. We can directly see education is having 0.22 impact on annual income. Job experience is having 0.64. Intercept, okay, this is 0.46 is called as square multiple correlation, which is like in regression adjusted R square, or it is called R square. 0.46 square in regression equations. Right. Now what is the difference between unstandardized and standardized? Already we discussed. When I say unstandardized, I am getting mean and variance. We can see this is mean and variance, this is also mean and variance, and this is intercept minus 54.59 is intercept. And on error, always mean is kept as 0. We have only to calculate about the variance. We can check about this means and variance in my previous videos, which I prepared to explain why we consider means and variances of different sample populations. Okay, this is the data. Let me go for uText. In this, let me see estimations. Okay, in estimations we need to check whether it is significant or not. Education impacting annual income. Estimation is 20.358, where P is all 3 stars means 0.00. We already discussed if P value is less than 0.05, it is significant. The same is the case with job experience impact on annual income. Okay, this is standardized values. We got 0.22 in education impact on annual income, 0.639 job experience impact on annual income. Okay, now this is for all the respondents what we have in the analysis. Now coming to the main point, how to convert this into groups. Like you can see here, I have in the gender, I have males and female. 1 means male, 2 means female. So I want to see, is there any difference between male and female, and what is the estimation for male and what is the estimation for female. This is what we are going to check in this video. To do this, let me come for input path diagram. Now in this square you can see group number 1. Now what we do is we will divide the total respondents into two groups, that is male group and female group, and we will be seeing what is the impact of education on income for male separately and female, and as the same way job experience on annual income for males and females separately we are going to do. To do this, it's simple. We can do is I'll click on this group number. Now system is proposing with a default group that is called group number 1. I'll remove the name. I'll call it as male. Okay, one group is created. I want to go for the second group. I simply say new. So first group male is created. Now second group I got group number 2. Let me remove this group again and write as female. And now don't say new or delete, simply say close. Once I say close, I have two groups, male group and female group. Fine. Now for male and female I need to specify from my file, that is data set, who are males respondents and who are female respondents. For doing this I go for select a data file. Okay, if you observe in the earlier case I have having only one file, but now see group name, I have two names of a group, male separate group and female also separate group. So first male is there, 500 respondents are there, but they are males and females. Now I am going to specify who are males in this. I go for grouping variable. My grouping variable is gender. Say OK. And the grouping value, click the button called group value. Now one is male, so I am selecting 1 and say OK. Now you can see male group we have value is 1 for male, and I have 245 members, around 50% of males are there. Now to do for female, I select female. Now there is no working file here, so what I can do, I say file name. I select from where I have my file, multi-group analysis file, select it. Now next is grouping variable. Select the grouping variable gender. Next is group value. The group value is 2 because for females we discussed it is 2. Say OK. Fine. Now this is how I have initially created two groups here, male and female. And what I did next is I have gone for selecting data files. In these data files I have assigned the file names, specified what is a variable, and specified the values, that one is male and 2 is female. System automatically considered how many people are there in the total. Males 245 members out of 500 and females are 255 members out of 500. Now say OK. Done. This is multi-group grouping is done. Now I am going for analysis part. I go for calculate estimate. Now system gives the same warning. Do correlation for education and job experience. I say proceed with the analysis. Now we can see we got male and female. Let me see the output path. Okay. This is output path, and this is unstandardized, and this is for standardized. Now let me see for standardized what is the value we get for male. Male is 0.25 and male job experience impacting an annual income is 0.68. What's for females? Yes, it has changed. Education It was earlier 0.25, but it is now 0.19. And job experience 68, it has become 0.60. Okay, we have now two groups. This is multi-group analysis. Within two groups, I am doing the analysis. Let me see the output, that is view text. In view text, I want to go for estimations. Now here it is clearly specified that it's a regression weight for male, and this is estimations what we have for male 22.962, and job experience is very less. But if you see standardized is changed, education is having less impact on annual income, whereas job experience is having more impact on annual income, but both are significant. This is males I am showing you. I can show you for females. Okay, for females you can see the same thing. Education on annual income is 0.19, whereas job experience impacting annual income is 0.64. So this is how we can do very simply that grouping and group analysis can be done. Okay, let me see square multiple correlation. Here for males it's 0.521, and for females it is 0.4. This is the variance that is explained by independent variables on dependent variable, which is R square in regression analysis. So males it is 0.5 to 50% of variance is explained, but female it is not complete, it is only 40% of variance is being explained. In the same way we can check for model fit, but for model fit we don't have individually for males and females, because the model fit is for the total model. We have a single model. Within a single model we are comparing about multiple groups. So this is what we are discussing. Model is one, so model fit will be same for both models, that is both groups. So this is what we get here is for the total model. I just summarize once again. In this session what we did is we have taken one example of to study the impact of education and job experience on annual income. We did it in a general way. After drawing the diagram, after doing all settings, we have checked for total respondents. Later we have did grouping of males and females, and we have done the settings for doing this males and females, and multi-group analysis is conducted, and we checked what is the for males what is the estimations and for females what is the estimations. Right, you can see here males is having 0.25 education impact on annual income, but for females it is 0.19. My question is it significant or not significant? Is there any difference between the impact of education on annual income between male and female? This is my question. To answer this question, we will be seeing the next video, where I am going to explain how to do multi-model analysis. We will be developing multiple models and we will be checking is there significant difference between males and females? Right, is there or not, we will be seeing for the next video. Thank you for watching this video.